now that we've created our schematic symbol and verified it, now it's time to create our PCB footprint. So in the data sheet, you'll be able to scroll down. Usually it's towards the back of the data sheets, I find. There will be a section. Let me just keep scrolling here. So there's a section in this data sheet called Package Outline. And it basically provides you the dimensions of all the packages the chip will come in. So for example, I know that this chip here, so the package that it uses is an 8-XFDFN. It's a very confusing name. And keep in mind that there are also multiple names for packages. So the supplier device package names are 8XSON and then this one here. So the package that that this chip will come in when we order it can have any of these three names. So keep an eye out for any of these three names in the datasheet. Yeah, it's just good to check if the package name has any aliases that it goes by, just so you're not like looking for a package number that doesn't show up. But you'll see, I think it's actually this one here, the XSON8. This is the package that we're designing around. So you can see that it basically lists all the dimensions here in this table. This is not what we want. We'll come back to this a bit later. If we keep scrolling down further, there's actually a section, I think it's right here, called Soldering Pcb Footprints. And all data sheets, have a section that's similar to this, where they literally tell you the dimensions for the footprint that you're supposed to make, or the dimensions of the pad placement. So as you can see, I think this is the one as well. Yeah, that looks like it. As you can see, yeah, it lists the aliases as well. So yeah, just make sure you check for those. And these are all the dimensions of the footprint that we need to make sure we satisfy. So let's go into Altium and let's get to it. So we're going to go File, New, and we're going to go Library, and we're going to create a PCB library. The first thing I'm going to do is I'm actually going to save this, and we're going to save this in our Altium Libs PCB folder, and I'm just going to copy the name of this package. So I guess we can use this name, and the dimensions of this package, it also says that this is the dimensions are 2 by 3, so 2 millimeters by 3 millimeters. So sometimes it's also good to include the dimensions in there if you can, because some packages have the same name to them but have different dimensions. So what I'm going to do is I'm going to go back to Altium, paste this name in. Wow, that completely glitched out. And now it's not working. Great. 8-XFDFN. XFDFN. Oh, I actually got it right. Amazing. And then I'm going to go -2 by 3. Excellent. And then I'm going to save that. Perfect. Alright, I'm going to go to Tools. And Altium has this very handy tool called a Footprint Wizard that we can use. So this wizard will help you create PCB component footprints. Duh. And the first thing that it asks us is select from the list the pattern of the component you wish to create. So as you can see, we can create footprints, or Altium will walk us through the creation of footprints for a variety of components. So if we want to create a footprint for a capacitor, we select capacitor. If we want to create a footprint for a diode, we can select diode. And just many other components. I almost always exclusively use the Footprint Wizard. Very, very, very rarely. The Footprint Wizard won't be able to create a footprint for a component that I'm trying to make a footprint for. So you're always in good hands with the Footprint Wizard. Since we're creating a surface mount IC, that's not a BGA, we're going to choose the small outline package for the type of component we want to create. And since we're in Canada, I'm going to be using metric measurements. It's always a good idea to stick with metric measurements because sometimes data sheets won't list the imperial measurements for the pad dimensions, but I've never seen a data sheet that's not listed the metric measurements for the dimensions of the footprint. So always just stick with metric. So we need to now specify the dimensions of the pad. So this is where the data sheet comes into play. So I know the height of a pad, that's going to be the length of this edge here, that's going to be 0.250 millimeters. So 0.25. And the width of a pad on this IC, actually doesn't straight up tell us, we have to do some math. So I know the outer edge of this pad to this pad is 4 millimeters, and I know the inner edge of this pad to this pad is 2 millimeters. So that means each pad has to have a length of 1 millimeter for this to add up to 4 millimeters. Damn, pretty hard math, I know. So I'm just going to go back to Altium. So 1 millimeter. Perfect. And now we have to list the spacings between the pads. So the vertical spacing between each pad in this chip. Let's just take a look at that. So from the center of this pad to the center of this pad, which is what Altium wants, that's going to be 0.5 millimeters. So 0.5 millimeters. Perfect. And the horizontal spacing between pad centers, keep in mind, that's what Altium wants. That is going to be, well, I know from pad edge to pad edge, that's 2 millimeters. And I know this distance has to be half a millimeter, which means we have half a millimeter plus 2 millimeters plus another half a millimeter. That's going to be a 3 millimeter horizontal spacing between the pads. So I'm going to do that. And what is the width of the outline? Usually, I just never bother with this section because Altium tries to guess the outline for the package, and it's just always so bad. So I just leave this as default and delete whatever silkscreen Altium decides to put in. And how many pads should this have? I know this chip is 8 pins, so I'm gonna select 8. And we need to define the name of this package. So I'm just going to use the same name as what I did before. So 8-XFDFN-2x3. Yeah, so just make sure you have the name of the footprint the same as the file name. And we're going to select next, then finish. And wow, look at that. It automatically generated the spacings for all our pads and sized the pads correctly. And yeah, this outline's very ugly, so I just deleted it. I just want to draw your attention to the PCB Library panel. If this doesn't come up by default when you open up a PCB lib file, just go to the panels button in the bottom right corner, make sure that's checked off, and you'll be able to see it somewhere on your screen. So you can actually store multiple footprints in a PCB lib file. Right now, we always store one footprint for PCB lib file. So basically, since I can have multiple footprints in a PCB lib file, but we only want one, I'm going to delete this one. This is just the default footprint that pops up when you create a PCB lib file. So we don't want this. The footprint wizard automatically created a footprint for us. So I'm going to delete this guy, and you can see that this one's here properly named, same as the file name. So we're all good there. The next thing that we want to do is we want to go to our checklist here, and I always like to use the footprint checklist as a guide for what I need to do to create a proper footprint. It's pretty simple actually. So the first thing that's on this list is we want to ensure the pin 1 marker is clearly labeled. So when we label a pin 1 marker, we always just place a little dot beside pin 1 of the chip, so we know which pin is pin 1 when we look at the board. And this will help us determine the numbering for all of the other pins. Since IC pin numberings, we always start in the top left, and we go down. So 1, 2, 3, 4. And then when we get to the other side, we count up. So 5, 6, 7, 8. So we need to have a point of reference, and that's what the pin 1 marker is for. So I'm going to place a full circle here, and make sure when you place the full circle, you're going to want to place it in the top overlay. And I always like to use a 0.25 millimeter grid when I'm doing this. So let's just zoom in here, and let's just place this guy right in here. It's nice in line with the pad. So I'm just going to do this, and I'm just going to edit the properties of this circle. So right now it's a circle, but we want it to be or a circle. It looks like a donut, really. But I'm going to change the radius to like a very small value, so 0.01 millimeters. And then it'll just be, you know, like a tiny little dot. So that's the pin 1 marker. That's what we want. So I'm going to check that off. So datasheet or IPC footprint generator in Altium for creating components. This is basically saying, okay, did you look at the datasheet when you're making all the dimensions for the pads and their spacing, which we did, and we used the Altium footprint generator. As long as you're looking at the datasheet and creating, getting your dimensions from the datasheet, yeah, that's all I really care about. Yeah, just make sure you're getting it from a reliable source and you're not just downloading a footprint off the internet. So the next thing you need to do is ensure the pads are named correctly according to the schematic. So as you can see here, Altium automatically named all the pads for us. So the designator for this pad is 1, designator for this pad is 2. And if you remember when we were doing the schematic symbol, this does line up with what we saw in the datasheet. For ICs, it's pretty straightforward since Altium automatically names things for you. So that's a good check mark. And then we want to ensure the solder mask expansion is set to 0 for large components, or set to 2 mils for small/fine pitch components. I classify this IC as small/fine pitch, so I'm just going to select all the pads, and I'm going to go to properties here. So if we select all the pads, we can edit all their properties at once. And there's a section called solder mask expansion, and we want to manually edit this, so I'm clicking on the manual button. And as you can see, we have our dimensions for the solder mask expansion in millimeters. If we want to get that to mils, what I'm going to do is I'm just going to deselect all these and press Q on my keyboard. You'll see my grid axes have now changed to mils. So that's how you switch between millimeters and mils. So if I press Q again, it's back to millimeters. Let's just select all these pads, and let's just set this to 2 mils now. Perfect. So let's just get back here, check that guy off. Ensure footprint names are general enough if possible. So like I said, we always name footprints based on the case or package of the component, so it's very general. So that's a check mark. Ensure mechanical layer 1 is deleted from the footprint. So as we have, since PCBs operate on a layer system, so we have a top layer of copper, a bottom layer of copper, and we have a layer for our silk screen or any text we print on the board. That's our top overlay. We also have layers for mechanical items such as 3D models or outlines of 3D models that we can use in assembly drawings, stuff like that. And you can have many different mechanical layers. So I can have like a mechanical layer 10 or a mechanical layer 100. So as a team, we've chosen to use exclusively mechanical layer 13 to house the outline and 3D model, and we place a center cross on mechanical layer 15. And we don't use mechanical layer 1 for anything. So what I'm going to do is I'm going to go to the View Configuration pane. I'm going to click on this. And basically you'll see that we have all of our layers listed. So I'm going to select mechanical layer 1. I'm going to right click and I'm going to select delete layer. Perfect. And we're going to add a new mechanical layer, and we're going to be working on getting a 3D model in here, so we want mechanical layer 13 for that. So I'm creating a new mechanical layer, calling it mechanical 13, and we're defining it as layer 13. So I'm going to click OK. So we've now created mechanical layer 13, and I want to place a 3D model of this component on our footprint. So in order to do that, we have to find a 3D model of this component. And there are a few very good websites that I like to always search when I'm looking for components. And what I usually do is I just search the package or case number in the search bar on these websites and see if anything pops up. So the first website that I like to use is 3D Content Central. This is my #1 go-to for 3D models of electronic components. So you can see I searched up resistor here, and we get a bunch of resistors that pop up, or 3D models of resistors we can use, which is great. And there's many pages of them. If we search up, our package for this component here, and let's just make sure that's typed in right. Yeah, we get nothing that comes up, and I've already searched this website, so I know for a fact that there's no 3D model of this package on 3D Content Central. The next website I like to go to is GrabCAD. GrabCAD, you can also find like 3D Content Central, a bunch of 3D models for electrical components. Another great website is SnapEDA. SnapEDA is basically a website where you can also download not just 3D models for components, but footprints as well. If you do ever download a footprint from SnapEDA, please check the data sheet to make sure the dimensions are correct, and as much as you can, try to make your own footprints. So I searched the model or package for this chip in SnapEDA, and usually when you're searching for things on this website, you actually search it by the part number. So if we search up the part number for a chip, that's how you're really supposed to use SnapEDA, is just searching the part number. And as you can see here, it does pop up, but we don't have a 3D model. It says 3D model not available. But a nice little trick that I like to do is if you actually search up the package, a bunch of other part numbers will pop up, but some of them might have the same package, like this one here. As you can see, that looks very similar to what we see on DigiKey. It's actually the same image. So if I click on this and actually just have it up in a tab here, you go to the 3D model, that looks very similar to what we have. It actually says 8-XFDFN, which is what I've been typing in. So I'm going to download this 3D model. This is a good 3D model to use. Let's get this out of here, and it downloads it as a step file, which is a suitable file format. So I'm going to cut this. We're going to go to our Altium Libs, go to the models folder, and I'm going to get this guy in here. And I'm just going to rename this 8-XFDFN-2x3. Perfect. So whenever we name our 3D models, we name it the same as the package name as well. So everything has the same name. And I'm going to go to the place menu, or press P on my keyboard, and I want to place a 3D body. So it's going to bring up File Explorer here. So I'm going to go to where I have my Altium libraries. I think it's in here. Altium Libs. There we go. Models, and it's right there. That's the model that we want. So if I open this, and it'll just bring up this purple rectangle, I'm just going to place it anywhere in here. So if I go into 3D view now, we'll be able to see that we have the 3D model loaded into Altium. It's a little lopsided, but it's loaded into Altium. Something that's a little bit weird that happens to me specifically is Altium will automatically override the color of the 3D model to a very boring gray. So if you go to the properties panel, just make sure that this override color checkbox is not selected. I think that's just a personal thing on my end. But if that does happen to you, make sure you check that. But now you can see that the 3D model is looking a lot nicer. It actually has some natural color to it. And if we go back into 3D view, we want to be able to align the pins of this 3D model with the surface of the pads that we've created. And there's actually a tool in Altium that lets us do that. So if I go to the tools menu up here, or you can just press T on your keyboard and it'll automatically bring it up. We can go to 3D body placement, and align face with board is what we want. So we're going to select the 3D model that we want to align the face to the board of. So that's this one, of course, and as you can see, we can select all the different faces of the 3D model. So I'm just going to select the bottom on one of these pins, just click that, and then now you can see that we have the 3D model aligned properly with the board, I guess you can say. The next thing I want to do is go here, and what we can do is we can actually click edit and go to set reference and set the reference to the center. So what that did is it set the location of 0, 0 on the footprint coordinate grid to the center of the footprint. So Altium automatically knows where all these pads are, and we'll set the origin to the center of where all the pads are, or where the center of the component will be. And what you can do is if you hover over the 3D model and hover close to the center and just left click it to drag it, it'll automatically snap and drag it right by the center of the 3D model. So all we need to do is drag the center of the 3D model right on top of the origin there, and it should be aligned up with the pads, as you can see. Right, there you go. So it looks all aligned up there, and you'll notice that the pin 1 of the 3D model. So if we look onto the 3D model here, oh my god, yeah, that's the pin 1 marker of the chip. That's physically on the chip, and this is the pin 1 marker on the board. So we want this dot to be oriented on the correct pad. So we need to rotate this component by 180 degrees. So if I select the 3D model and double press spacebar, rotate it by 90 degrees, press it again, rotate it by 180 degrees, everything should be aligned up. And whoa, my 3D view is being very fidgety today. But if we look to the bottom of this, yeah, you'll be able to see that it lines up with all the pads. Something that I noticed just now is that the edges of these pads are rounded off, whereas the pins on this package are more rectangular, so they end up at 90 degrees. So I'm actually going to go and reselect all the pads here. And what you can do is you can change the shape of the pads. So under this pad stack header, there's a label called shape, and you can change the shape to rectangular. Altium just makes the shape of the pads round by default, rounds off the edges, but I'm going to make these rectangular. So if we go there, we see that lines up very nicely. And I also noticed an error that I made earlier on, is where I actually didn't extend this pad outwards, because if we pay very close attention to the datasheet of this component, pin 1 of, or pad 1, I guess you can say, or pin 1 of this chip, whatever, is slightly longer than all of the other pins by 0.1 millimeters, as you can see here. So we need to extend the length of this pad by 0.1 millimeters. That's why the 3D models are also useful, because you can actually use them to catch errors that you make. So I'm just going to go back into millimeters, and again, under pad stack, we can edit the dimensions of the pads. So for pad number 1, I'm going to extend this out by 0.1 millimeters. So that extended outwards, but we want this edge of the pad to be aligned up with the outer edge of this pad. So I'm also going to go up to just under this properties header, you can also edit the location of the center of the pad on the coordinate grid. You can do this manually just in these text boxes here. So if I do negative 1.5 1.45 millimeters, it should move this pad over by half a millimeter, which means the edges are now all lined up. And now if I go to my 3D model and look underneath, that looks correct. Very nice. And yeah, also just an FYI, you can also literally just press Control F if you want to flip the model in 3D view by 180 degrees if you want to see the top side and the bottom side. I don't know why I'm dragging this around like this and fidgeting it everywhere. I guess just a me problem. But there you go. So that's the next thing on the checklist done. So we deleted mechanical layer 1, and oh, we also want to create an outline of the 3D part. So we're going to go here, and I'm going to scroll back up. So this is where we need to go back to the package outline section. So we need to create an outline of the package on mechanical layer 13. And the outline of the package is basically just going to be a rectangle, excuse me, with these dimensions. So I know that the width of this IC is going to be dimension E. And if I look at that, it's going to be, well, it looks like it's 3 millimeters, which is what we saw on DigiKey earlier. And I know the height of the package, or dimension D, is going to be 2 millimeters. Alright, so if I go back in the Altium, that means if I'm going to be placing an outline of the package on mechanical layer 13, I want to place a line. And I want to make sure that we go over 1.5 millimeters. And if you look in the bottom right hand corner, you can see the X and Y coordinates of my cursor. So I'm going to go over 1.5 millimeters. And then I'm going to go up by 1 millimeter. Right? So that should bring us to the top corner of our package outline. So I'm going to create a line starting here. And then I'm going to move down by 2 millimeters, right? Move over by 3 millimeters, and then I'm going to move up by 2 millimeters, and then just complete the rectangle. And then that's the outline of our integrated circuit, which is very nice. And you can see that it lines up with the outline of the 3D model, which gives me confidence that this 3D model is correct. So now we can officially check this off on the checklist, and we want to ensure a center cross is available on mechanical layer 15. So I'm going to create a new mechanical layer, and I'm going to call this mechanical layer 15. Do this very quickly, and now we want to make sure we're on mechanical layer 15 when we place the center cross. So I'm going to place a line, or I press P on my keyboard, then L on my keyboard. That's the keyboard shortcut for it. Or you can just go to place line. I just want to make sure I'm explaining that, making sure that's clear so you guys know. And I like to stay on a 0.25 millimeter grid for this, for small ICs like this, and for larger components like inductors, I like to bump it up to a 0.5 millimeter grid. But stick to 0.25, and I just like to click in the center of the component and then just go up one, and then just go out, and then go out, and then go out, and then that's how you make the center cross. Alright, so the last thing on the checklist is we want to ensure the silk screen is available for larger components to indicate orientation of large component. So basically, if you have a very large component like an inductor or something like that, you want to make sure that we outline the component not just on mechanical layer 13. We won't actually see this on the board, but on the top overlay. So the text or graphics printed on the board, right? So we can see how much space that package takes up on the board, and we know not to place any components underneath that. The same thing goes for even small ICs like this one. You'll see that there's a little bit of a lip here, so the package sticks out an extra little bit beyond the pad. So we need to make sure that when we're doing our routing on our PCB, we know that this package sticks out a little bit, and we indicate that by putting a little bit of silkscreen there to just say, hey, the package sticks out this far beyond the pads, just so you know. So what I'm doing is I'm just placing two horizontal lines that are just overlapped with the outline that we already made on mechanical layer 13. So that way we know that when I'm routing the board, I cannot place any components on or past this line. So for the smaller or shorter edge of the package, the pads actually stick out further than the package edge, so we know that we actually physically can't place components that'll intersect with this edge of the package because it'll intersect with the pads, but we already know those are there when we're doing our routing. It's just this little lip here you gotta be worried about. So things like that, make sure you're compensating for. So that means that's checked off. And ensure diodes have cathode 1. We're not even using a diode, but ensure diodes that have cathode as pin 1 and a line drawn on the cathode terminal. So make sure that if you ever have a 3D model for a diode, that that we indicate which pad is the cathode, and the 3D model has a cathode line on it. Just a heads up there, but we're not worrying about this for this example. And that actually concludes the creation of this footprint. So if I go into 3D view, and actually let me just change my background here to something a bit darker, you can actually see what this will look like. So you can see the silkscreen outline there saying that how far the package extends out to, and we do have the pin 1 marker here as well. So I say that this footprint is very complete and satisfies all of our team standards, and of course get another person on the team to check your work whenever you're making a new schematic, graphic, or a footprint.